All right, hello everybody. I only have 5 minutes until the bell's going to ring, so I'm going to try to do this recording as quickly as I possibly can. So this video is about angular and linear velocity, and most of you probably remember from like physics and science classes that velocity is just basically you're talking about speed here. So if you are looking at angular velocity, you are talking about how fast an object spins, rotates, or revolves in a circular path around a center point. So, you know, in a circle you have 360 degrees, and we've been doing degrees in radians. With angular velocity, you're just saying how fast is something spinning. Okay, think about a top, how fast is a top spinning and all that fun stuff. Linear velocity is how fast an object moves through space. When we were tracking how fast the Earth rotated around the sun, that would be the linear velocity, was how fast it was moving through space. Okay, with angular velocity, you want to use angle measurements per units of time. Sometimes you'll get revolutions per minute. Sometimes you'll get degrees per second or radians per hour. If you have linear velocity, you're looking at distance per time in units. Sometimes if it's a car, it may be miles per hour. Or if you have a racer, it could be feet per second or centimeters per day. If you think about how far a turtle moves, it may be feet per second. I don't know if a turtle moves that fast. Anyway, inchworms may be centimeters per day, or like how fast something grows may be centimeters per day. Anyway. All right, so let's look at some information and annotations for velocity with linear and angular velocity. This v sub theta, that's how you notate angular velocity, and v sub L is linear velocity. Okay, the r is the length of the radius. Okay, so if you're looking for angular velocity, it's just going to be radians. Your angle has to be in radians. So if you are given degrees, you need to convert it into radians and then divide it by whatever the units of time, whether minutes or seconds. Oh, there's the bell. I have the door locked, so hopefully people won't be banging on the door. Linear velocity, you have to multiply your angular velocity times the radius. Okay? So linear velocity, it's still something is going around in a circle, and you want to know, okay, maybe you have a ball attached to a string, and somebody's right here, and they're spinning that ball around. Okay, linear velocity is going to tell you how fast that ball is moving as it rotates. Angular velocity will be how fast the person in the center is spinning. Okay. All right, so let's look at a problem situation. You have a dad taking somebody to a park, and he's pushing him on a merry-go-round. Okay, so the merry-go-round is rotating around the center point. The kid is right here, 5 feet from the center, so the kid is his radius is going to be 5, and the dad's radius is going to be 8. I'm going to go ahead and show you these answers since my time is limited, and then I will walk you guys through it. So if you're looking for how many degrees is 3/4 of a revolution, so let's say the dad runs around 3/4 of the way around. So that's 3/4. You get 270 degrees. You need to convert that into radians. So you're going to multiply by pi and divide by 180, and you get your angle is 3 pi divided by 2. To find the distance that dad runs, that's your linear velocity. You multiply it by the dad's radius here, and you get the linear velocity. And then in feet per second, what is dad's average speed? You need to convert. So this is the velocity is feet. It's 37.70 feet, but it takes him 3 seconds to move that far. So you get 12.57 feet per second when you divide by 3. Okay, is Junior moving at the same speed? Well, even though they're rotating the same amount, Junior is actually going to be traveling at a different speed. He's traveling at 7.85 feet per second because his radius is a different length. His radius is 5 feet. So when you do the conversions, you'll find out that Junior is actually traveling, or his speed is slower than his dad's. All right, that's the end of the video. I hope you enjoy it. I hope you're ready for the warm-up problems tomorrow, and I will see you tomorrow.